Hey everyone, Mr. Skelton here, back at it. Lesson 5, Unit 9. Today we're going to be talking about permutations versus combinations, or permutations and combinations, and the difference between the two. And it's going to allow us to just work with different sets of numbers to find possibilities that are out there. And there's really one difference and one difference only between the two, and one is where order matters, and the other is where order does not matter. And so we're going to talk about that more specifically in the examples that we do. So let's just jump right into it. We have two examples here. We have an example involving permutations, and we have an example involving combinations. And you can see the work that's there already, but let's talk about what you see and see if it makes sense to you. So in this first example here with a permutation, an example of a permutation with classroom awards, you're selecting the first, second, and third place prize for the year from the class of 24. What does that mean? That means that the first place is a specific person. Once that person wins, they are no longer eligible for any other award. So that person is out, which then leaves you with 23 options for second place. That person is out. And third place for third. Nobody can repeat as winners. And so you would just write your answer as this. And we kind of did that in the last lesson where we were doing the counting principle, right? So we could write it as 24 factorial over 21 factorial, and again, that's gonna yield this. Remember that we just went 24 times 23 times 22 times 21 over 21, 20, 20, and all these end up crossing out all the way down to 0, so all you're left with is this. Now, what is new to you is this. And what this basically means is this is the total amount. So we have 24 total people in the class. That's the first number listed. P stands for permutation, and 3 represents order, okay? In this case, with permutations, the order matters. When we're selecting a first, second, and third place prize from the class, order matters. There's an order in who we're choosing first, second, and third. So in this case, the biggest difference is that permutations have to have order about them. That's how you know the difference between a permutation and a combination is order matters. Now in your calculator, what you would do to calculate this, let's see if I can get rid of the glare here. On your calculator, you would, to calculate this, instead of doing all of this, which you could go 24 times 23 times 22, but what you can go is hit 24, and then this PRB, probability button, you hit that, and you'll see both an example of a permutation and a combination, and there's your factorial button, which we learned last lesson. And you just hit enter on the NPR because that's going to be our permutation, and then you just hit the number 3 because there's 3 possibilities of first, or there's an order of 3, first, second, and third, and then just hit equals, and we should have 1, 2, 1, 4, 4. So 12,144, okay? And you would get the same thing by going 24 times 23 times 22. You get the same exact thing, all right? So let's show you an example of a combination. So a combination, obviously, is where order does not matter, okay? So we're selecting the top 3 students from a class of 24. So we're just picking the top 3 students, and we're just giving them like a certificate or something like that. It's not in a specific award. It's not a specific place, first, second, or third. We're just saying, hey, the top 3 students get this award, and it's in no order. So, you know, Al, Bill, and Chris, right? So Al, Bill, and Chris, out of those 24 students, it could be Al, Bill, and Chris. It could be Bill, Chris, and Al. It could be Chris, Al, and Bill. My point is, it's repetitive. Those 3 people are going to show up more than once. In fact, you have basically 6 options for them because there's 3. So basically 3, 2, and 1. Once you pick the first person, then you have 2 options for the second, and then 1 option for the last. So you need to divide out the repeats, okay? Because order doesn't matter, so we don't want those repeated top 3 to count in the total amount of options we have. So that's an example of a combination where order doesn't matter. And what you need to do is make sure you divide out 3 factorial, or however many you had. If this was selecting the top 8 students, it would be 24 divided by 8 factorial, because you'd have repeats where there's those 8 kids could repeat. So it can be a combination written like this. We use combination when we know that order does not matter, and it's very similar to what we just did. 24, hit your probability button. Okay, let me clear this, start over. 24, hit your probability button, and you just use your right arrow key, scroll over there, hit enter, hit in a 3, hit enter, and we have a massive number there, 2, 3, 7, 0, 8, 7, 6, 4, 2, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3. Massive. Okay, those are all the combinations of selecting the top 3 students from a class of 24. That's a combination where order does not matter. Okay? We could also calculate it this way as well. And I would always, if you're going to calculate it this way instead of using the calculator, you would want to go 24 factorial divided by 21 factorial and then divide that by 3 to get rid of those repeats. Okay? All right, let's do some more examples here. This is almost identical to what we just did, so I'm not going to spend too much time on it, but again, I'm just going to highlight the differences between the two. So this is an example of a permutation. You want to elect a president, a VP, a secretary, and a treasurer for your club from the 12 members. So order matters here. You're selecting a specific president, a specific VP, secretary, and treasurer. It's not just random people, 4 random people in those spots. You want a specific person, so order matters. And so then that means you would use a permutation, okay? You could do it this way in your calculator. You could write it as 12 factorial over 8 factorial, whatever way you choose to get your answer. Second is a combination. You want to elect an advisory committee of just 4 people from your members. So again, it could be, you know, Al, Bill, Chris, and Dan. All right. Well, those 4 people, the order doesn't matter. We're just picking 4 random people to go, and so you could have Al, Bill, Dan, or Al, Bill, Chris, and Dan. Bill, Chris. I mean, it would repeat. So we divide. Remember, if there's 4, you're going to divide by 4 factorial. So that would be an example of a combination because the order does not matter. Both ways are sufficient in terms of calculating it. Most people are going to stick with this now that they know it and how to do it in their calculator. Okay. So let's take a look at this example here. This is kind of a fun example. There's an error here. There should be 50 numbers. There's not 5 numbers on the dial. There's 50 numbers, right? 0 through 49. So Homestead lockers have 50 numbers on the dial. How many locker combinations are possible, right? We always refer to these as locker combinations. What's your locker combo, right? How many combinations are there are possible? Assume that you cannot, for the sake of the example, have a repeat number. Okay, well, what does that look like? Really, that's going to look like this. We have 3 numbers. For the first number, we have 50 possibilities. Well, once that number is taken, so, you know, let's say we have like 3, 33, and 12 as our locker combination. Well, if that first number is a 3, 3 cannot be repeated, so how many choices are left for your second number? 49. Once that number 33 is out, you have now 48. So what is this? Is it really a locker combination? It's really not, right? It's a locker permutation. It's not a combination at all because order matters. Those numbers, assuming here that we cannot have them repeat, that order does matter. So again, we could write this as a permutation with 50 and a 3, and we can calculate that by just getting the calculator out of the glare. So we'd go 50, probability, permutation, 3, and we have 117600, so 117,600 possible ways to get your locker permutation, not locker combination. All right, flipping it over. We used to teach this lesson around Valentine's Day, so you're going to see a Valentine's themed questions here for the last 2, so bear with me. You decide which it is. Grant gets ready for his big date by selecting 5 roses out of a possible 15 at the local floral shop to present the lucky young lady when he and his mom go to pick her up. So we're trying to figure out the possible choices of roses. So the first thing you have to decide is this. Is this a permutation or a combination? So just put yourself in a situation. If you're going to the store and there's 15 roses and you're just picking 5, right, in the arrangement, the order is really not going to matter. Now, some of these questions can get a little sticky. You can overthink this and say, well, the order would matter here on this. I have a specific order. So don't read too much into it. We're just selecting 5 roses, so it really doesn't matter what roses we pick first. We're just picking 5 out of the possible 15. So that's going to be a combination. Out of a possible 15, we want 5. And so we would just take our calculator out and go 15 probability. It's a combination, 5 roses. And we're going to have 3,003 possible ways to arrange those 5 roses out of the 15 that we picked up from the floral shop. Again, you could go 15 factorial over 11, 15, 14, 13, 12, 11, 1, 2, 3, 4, 5 over 10 factorial, and then divided by 5 factorial. Again, you could write it that way if you'd like. Again, most of us are going to stay right here because once we figure out whether it's a permutation or combination, very simple to just put it in your calculator. You don't even have to mess with the factorials. Last one here, again, love theme here for Valentine's Day when we used to teach this during that time of year. So again, bear with the love theme question here. So it says Grant then selects his 5 favorite songs to put on a CD out of the possible 15 he knows that she likes. He puts them in a particular order. Kind of give it away there, right? Particular order, hoping it will help win her over. So he wants to put these 5 songs. Everybody, you guys are probably too young for having a mix on the old CD, but used to do that back in the day. Anyways, this is a permutation. Permutation because order matters. So we got 15 total songs, 5 songs that we're going to put in a specific order. So we know we're going to have 15 times 14 times 13 times 12 times 11. 1, 2, 3, 4, 5. Order matters. Or we can just put it in our calculator as a permutation. So it's 15 permutation 5, and we have 360,336 possible ways to arrange, to put those songs in order on his Pure Love CD mix. Okay? So the biggest thing that I want you to take away from this lesson is really the difference between permutation and combination, and it's real simple. Permutations require order, and combinations do not. All right? So look forward to answering any questions you may have in class. Look forward to seeing you. Take care.